Welcome to our contribution to ICC AUA Turkey 2024. The topic possibilities and limits of AI-supported design and manufacturing processes in architecture. The leading persons behind this work are Professor Dr. Grunwald, Professor for Construction and Building Management at the Department of Architecture at the Yara University of Applied Science in Oldenburg, as well as two of our students, Yara Hirsekorn and Ansre, and myself, Yoshio Kawasaki. First, we introduce our research project in which we have dealt with parametric design and AR manufacturing technologies, among other things. In this process, we came across our initial problem, which prompted us to research this topic. This was followed by a study on the usability of different AI models for our approach. A case study was conducted and AI with the highest usability, and we were able to develop a working method with consistent results. Finally, we show the results and an outlook. In the research project Aufladen, which is funded by the Stiftung Innovation in der Hochschullehre, we are developing a digital teaching portal together with around 20 students. Aufladen is the knowledge-filling station where students have the opportunity to test and expand their knowledge in the context of digital transformation with so-called knowledge nuggets through practical, playful application in the form of learning videos, tasks, click tutorials, and quizzes. The research project offers space for various labs in which teachers can explore topics together with students through research-based learning and teaching. Aufladen offers labs on topics such as AI and the design process, parametric design, and AR technology. The lab areas of parametric design and AR technology are important for us today. Based on our research project, we have been able to create a course program where students have the opportunity to investigate building in combination with augmented reality and feasibility behind it. Before the construction process, the object in question must be designed and modeled. The designs were parametric structures. In the parametric design lab, it turned out that we were able to achieve the greatest learning success through prepared click tutorials. Nevertheless, a major problem emerged. The operation of the software is so complicated for beginners that they are severely restricted and cannot implement their ideas in the software. To create the designs geometrically, we use Rhino in conjunction with Grasshopper to then transfer the geometry to the AR glasses via the hologram software. Grasshopper is a visual programming interface and offers great possibilities for complex designs, but is associated with a steep learning curve. Students from our departments generally have no programming experience and often have no points of contact and therefore little understanding of programming. Here we see a project from the last semester that we designed, planned and built together with students. The bench is not overly complicated, but the code behind is. This entire script is necessary for this rather simple bench. We cover different areas such as the design process, the manufacturing process and the assembly process. Due to the complexity of the software, we came up with the idea of whether we could let the AI take the methodical knowledge about the software and include this step in our working process. Now we had to find a suitable AI for our approach. The main consideration was the workflow that the AI must be able to handle. Grasshopper offers the option of generating geometry via Python code. For us, this means that the AI must be able to translate our prompts into Python code. We can then easily read the output code into Grasshopper and check its function. If the code is faulty or does not achieve the desired result, we can return the error message to the AI and it can improve the code based on this. We can repeat this iterative process until the desired result is achieved.
We've developed an evaluation matrix to evaluate the various AI models. The requirements are divided into the following points. We mentioned the three most important. Is the AI accessible in Germany? Can the AI understand and generate Python code? And can the AI use images to create shapes in Rhino with Python code? We tested ChatGPT 3.5, ChatGPT 4, the Edge Copilot, as well as Gemini and Claude 3. ChatGPT 4 proved to be the most useful for application. The AI is slightly more powerful than the Edge Copilot and is not limited to 30 queries, allowing for the development of much more complex shapes over the course of a conversation. With unrestricted availability in Germany and the ability to understand and generate Python code, ChatGPT 4 proved to be the most useful for application. Additionally, it can use Grasshopper Python code to create geometric shapes and describe complex geometric forms. Having selected a suitable AI, we proceeded with a case study. Methodically, we chose an iterative testing approach. The process begins with a simple shape, gradually increasing the complexity of the geometry. The AI generates the corresponding program code, which is integrated into the visual programming environment Grasshopper to create the desired structure in Rhino. The goal is to create the geometry exclusively through code lines generated by textual input. First, we had to understand how ChatGPT interprets 3D objects and how best to interact with the software, which we learned through initial failures. The first successful result was a cube. To generate this, we instructed ChatGPT to create a 1 by 1 by 1 meter cube in Rhino using Python. Next, we tried more complex structures like walls. Here's one result. After the wall, we developed a request to arrange multiple objects in a ring shape, generate random heights, and explore what is possible and what is not. A failure in generating more complex geometry with ChatGPT 4 occurred when it didn't quite understand how to build a vase. We then learned from your failures how to better define shapes. After further discussions with ChatGPT, we could convey our idea of a vase, resulting in a better and more promising outcome on which we could build. We then tried to generate a vase without a prior discussion. Without clear dimensions, this attempt was unsuccessful. In the process, we developed a method that ensures the AI produces consistent and reproducible results. We developed this method after failing to create a vase, opting for a simpler approach, the block structure. Each of the two adjacent axes consists of a block, making it easier for the eye to recognize and for ChatGPT's image recognition to identify. The method uses the 2x approach to eventually enable a reconstruction. The image shows a 2D view of a vase, and ChatGPT should generate the Python code based on the overall height, block dimensions, and respective width of the levels.
This video shows the process of generating with ChatGPT 4. First, we provide the AI with a description of the vase with the appropriate dimension. It then generates the corresponding code. Due to the complexity of the research, it needs to refine and ensure output is defined as A, which is standard naming in the GH Python scripting module in Grasshopper. Then Grasshopper is opened and the GH Python script module is inserted to input and test the code, with the results displayed in Rhino. Next, the Z variable is added as an input in the module. The Ansre sliders are connected to the three variables X, Y, and Z. The AI is instructed to adjust the code so the input variables can be modified via the sliders. Again, the output needs to be redefined as A. Now the new input the code in the Python module. The sliders can now be adjusted as the base shown in the video. ChatGPT provides information during the code generation process, including the libraries used, the function generated, and how to handle the code in Rhino and Grasshopper. The results of the videos can be seen here. As input, we constructed the AI to write Python code for Rhino Grasshopper to create a vase providing the correct dimension for the vase. In conclusion, we provide an outlook on the future steps. Next, we will be presenting the research results on AI in design and manufacturing progress in the architecture at the University Future Festival 2024. There will be a digital collection of results for visitors to experience. Building on this article, we will next attempt to incorporate AI supporting not only the implementation, but also in the preliminary design process and the concept development. This would allow the technology to support everything process stage. Thank you for your attention and enjoy the rest of the presentation.